Good morning children. We are going to see the rest of the topics in our lesson ray optics. Yes, we have seen what are the topics that we have seen earlier. We have seen what is a ray, what is beam of light. What is a beam of light? The collection of ray of light is called as the beam of light. Then we have seen various types of beam of light, namely parallel beam, divergent beam and convergent beam. Yes, the next topic that we are going to see is spherical mirrors. What are called as spherical mirrors? The mirrors that have curved surfaces are called as spherical mirrors. What are called as spherical mirrors? Spherical mirrors are the mirrors that have curved surfaces. Spherical mirrors are of two types, namely concave mirrors and convex mirrors. Spherical mirrors are of two types, namely concave mirrors and convex mirrors. Yes, what are called as concave mirrors? Concave mirrors are nothing but the mirrors that are curved inwards are called as concave mirrors. What are called as concave mirrors? The mirrors that are curved inwards are called as concave mirrors. What are called as convex mirror? And mirrors that are curved outwards are called as convex mirror. What are called as concave mirrors? The mirrors that are curved inwards are called as concave mirror. What are called as convex mirror? The mirrors that are curved outwards are called as convex mirrors. Yes. What are called as spherical mirrors? The mirrors that have curved surfaces are called as spherical mirrors. Spherical mirrors are of two types, namely concave mirrors and convex mirrors. Concave mirrors are the mirrors that are curved inwards. Convex mirrors are the mirrors that are curved outwards. Yes. Next topic that we are going to see is terms that are related to spherical mirrors. What are all the terms that are related to spherical mirrors? Yes, let us see the terms first. Aperture. Next is your pole. Next, center of curvature, radius of curvature, principal axis, principal focus and focal length. Okay. What are the terms that are related to spherical mirrors? Aperture, pole, center of curvature, radius of curvature, principal axis, principal focus and focal length. Yes, now what is aperture? Aperture is nothing but it is the width of the spherical mirror used for reflection. Thickness. Aperture is nothing but the thickness of the mirror that is used for reflection. Okay. Aperture is nothing but thickness, width of the spherical mirror used for reflection. Next, what is meant by pole? Pole is nothing but it is the geometric midpoint of the mirror. The center point of the mirror is called as pole. What is pole? The midpoint of the mirror is called as a pole. Next, center of curvature. The center C of the mirror is called as center of curvature. Next, radius of curvature. Radius of curvature is nothing but it is the distance between the pole and the center of curvature. P is nothing but it is the pole and C is center of curvature. The distance between pole and center of curvature is called as radius of curvature or represents radius of curvature. So what is radius of curvature? It is the distance between the pole and center of curvature. Next, what is principal axis? Principal axis is nothing but it is the line passing through the pole and center of curvature. Line passing through the pole and center of curvature is called as principal axis. Okay, what is principal axis? Principal axis is a line passing through the pole and center of curvature. Next, principal focus. Principal focus differs for concave and convex mirror. Okay, for concave mirror, the principal focus will converge. Converge is nothing but it will come and join at a point. Okay, it is focused at a point. For concave mirror, the principal focus gets converged. For convex mirror, the principal focus gets diverged. Diverge is nothing but it is separated from a point. Okay. Yes, we have seen what is aperture. Aperture is nothing but it is width of the spherical mirror that is used for reflection. Next is your pole. Pole is nothing but midpoint of the mirror is called as a pole. Next, center of curvature is nothing but that is the center point of the mirror is called as center of curvature. What is radius of curvature? Distance between center of curvature and pole is called as a radius of curvature. What is principal axis? That is a line passing through pole and center of curvature is called as principal axis. This line is called as principal axis. Yes, next principal focus. Principal focus differs for concave and convex mirror. In case of concave mirror, the principal focus gets converged. See here, the principal focus gets converged. For convex mirror, it gets diverged. This arrow mark represents the convergence and divergence. Okay, here it gets diverged, and in this case, it gets converged. For concave, the principal focus gets converged. For convex, the principal focus gets diverged. Okay, we have seen what is meant by spherical mirror. What are called as spherical mirrors? The mirrors that have curved surfaces are called as spherical mirrors. Spherical mirrors are divided out of two types, namely concave mirrors and convex mirrors. Concave mirrors are curved inwards, convex mirrors are curved outwards. Next, we have seen what are the terms that are related to spherical mirrors. Yes, what are the terms that are related to spherical mirrors? Aperture, pole, center of curvature, radius of curvature, principal axis and principal focus and focal length. Okay, yes, what is aperture? Aperture is nothing but width of the spherical mirror, thickness of the spherical mirror. Next, pole. Pole is nothing but the midpoint of the mirror. Center of curvature, center C of the mirror is called as center of curvature. Radius of curvature, distance between pole and center of curvature is called as radius of curvature. It is represented by the letter R. Next is your principal axis. The line that is passing through center of curvature and pole is called as principal axis. Principal focus for concave, it gets converged. For convex, it gets diverged. The next is your focal length. Is what is meant by focal length? Focal length is nothing but it is the distance between pole of the spherical mirror and principal focus. What is focal length? Distance between the pole of the spherical mirror and principal focus. What is meant by pole? It is the midpoint of the mirror. That is the distance between the midpoint of the spherical mirror and principal focus is called as focal length. Next topic that we are going to see is relation between focal length and radius of curvature. We are going to relate focal length and radius of curvature. Now, what is focal length? Focal length of the spherical mirror is half of its radius of curvature. So, 1/2 of radius of curvature. Focal length is represented by the symbol F. F is equal to radius of curvature by 2. Focal length is half of the radius of curvature. So, F is equal to radius of curvature by 2. Radius of curvature is represented by the symbol R. F is equal to R by 2. F is equal to R by 2. Here R is your radius of curvature. So, from this we can calculate R, right? R is equal to 2F. If you cross multiply this, R is equal to 2F. So, radius of curvature is equal to 2 times of focal length. 2 into focal length. Okay. This formula will help us to solve the problems related to focal length and radius of curvature. Okay. If we ask you to find focal length, what will be the formula? Focal length is equal to radius of curvature R by 2. If they ask us to find out radius of curvature, then the formula will be R is equal to 2F. 2 into focal length. Okay. Yes, what is focal length? Focal length is the distance between pole of the spherical mirror and principal focus. Next, we are going to relate focal length and radius of curvature. Focal length is half of the radius of curvature. So, F is equal to radius of curvature by 2. Radius of curvature is represented by the letter capital R. So, R by 2. From this, we are going to calculate radius of curvature. R is equal to 2 into focal length. Yes. The next topic is formation of image by a concave mirror. How image is formed in a concave mirror. First case, when the position of the object is at infinity. When the object is placed at infinity, how will the property of the image will be? How the image will be focused for us? It will be highly diminished, real and inverted. Highly diminished is nothing but the size of the image will be reduced. Okay. The size of the image will be reduced and the image will be real image and inverted. Inverted is nothing but it will be in the opposite direction, upside down. Okay. So, the image will be highly diminished, real and inverted when the object is placed at infinity. When the object is placed at infinity, the image will be highly diminished, real and inverted. Next, if the position of the object is at C, what is C? C is the center of curvature. If the object is placed at the center of curvature, then how will be the image? The image will be at the same size, real and inverted. Okay, the image will be at the same size, real and inverted. Next, if the position of the object is at F, what is F? F is nothing but it is at the focal length. If the position of the object is at F, the object will be highly enlarged. Enlarged in the sense it will be expanded. Okay, object will be highly enlarged, real and inverted. The position of the object and the image is placed beyond C. Beyond C is nothing but C here. This image shows when the object is placed beyond C. How will be the position of the image? The position of the image will be between C and F. The position of the image will be between C and F, and the nature of the image will be diminished, real and inverted. What will be the nature of the image in case of the object that is placed beyond C? The nature of the image will be diminished, real and inverted. Next, third case, the position of the image is placed between C and F. If the object is placed between C and F, how will be the nature of the image? The nature of the image will be enlarged, real and inverted. The nature of the image will be enlarged, real and inverted. Yes. First case, if the position of the object is placed at infinity. If the object is placed at infinity, the nature of the image will be highly diminished, real and inverted. If the object is placed at C, at center, how will be the nature of the image? The image will be at the same size. The image will be a real image, and the image will be inverted. It will be upside down. Okay. Yes. If the position of the object is at F, if the object is placed at F, what will be the nature of the image? Image will be highly enlarged, real and inverted. The image will be enlarged, it will be real and it will be inverted. Next, position of the image. If the image is placed beyond C, the position of the image will be between C and F. The nature of the image will be diminished, real and inverted. Next, if the position of the object is placed between C and F, if the object is placed between C and F, the position of the image will be beyond C. Position of the image will be beyond C, and the nature of the image will be enlarged, real and inverted. Yes, we have seen what is focal length. What is focal length? Focal length is half of the radius of curvature. So the formula for focal length is F is equal to radius of curvature by 2, R by 2. From this we can calculate radius of curvature. R is equal to 2 into focal length. Then we have seen the formation of image by concave mirror. How the image will be formed at the concave mirror. If the position of the object is at infinity, if the object is placed at infinity, how will be the nature? What will be the nature of the image? What will be the nature of the image if the position of the object is placed at infinity? The image will be highly diminished, real and inverted. What will be the nature of the image if the object is placed at C? If the object is placed at C, the nature of the image will be of same size, real and inverted. If the position of the object is placed at F, if the object is placed at F, the nature of the image will be highly enlarged, real and inverted. If the object is placed beyond C, the nature of the image will be diminished, real and inverted. If the object is placed between C and F, the object is placed between C and F, the position of the image will be beyond C, and the nature of the image will be enlarged, real and inverted. We have seen the formation of image by a concave mirror, right? Now we are going to see the formation of image by a convex mirror. How the image is formed in a convex mirror. Yes, first, when the object is placed at infinity, the position of the image will be behind the mirror. Okay, if the object is placed at infinity in case of convex mirror, then the position of the image will be behind the mirror. The nature of the image will be highly diminished. The image will be highly diminished, virtual and error. The image will be highly diminished, virtual and erect. If the object is placed at infinity, in case of convex mirror, the nature of the image will be highly diminished, virtual and erect. Next, if the object is placed between infinity and the pole, if the object is placed between the infinity and the midpoint, how will be the nature of the image? The nature of the image will be diminished, virtual and erect. The nature of the image in case of the object that is placed between infinity and pole will be diminished, virtual and erect. Yes. These are the two cases that we have seen in the formation of image by a convex mirror. Next, we are going to see the summary for what we have seen in these diagrams. Okay, in case of both concave and convex mirror, we are going to see the summary of the image formed by the concave and convex mirror. Yes. First, the position of the object in case of concave mirror. If the object is placed at infinity, first we are going to see the position of the objects, then position of the image, then how will be the size of the objects, then what will be the nature of the image. Okay. First, the position of the object. If the object is placed at infinity, then the position of the image will be at focus F, and the size of the image will be highly diminished. Then the nature of the image will be real and it will be inverted. Okay. When the object is placed at infinity, the position of the image will be at focus F, and the size of the image will be highly diminished. The image will be highly diminished. Then the nature of the image will be real and inverted. Next, when the object is placed beyond C, when the image is placed beyond C, then the position of the image will be between F and C. The size of the image will be diminished. The image will be diminished. And the nature of the image will be real and inverted. When the object is placed beyond C, the position of the image will be between F and the image will be between F and C. And the size of the image will be diminished. And the nature of the image will be real and inverted. In case of when the object is placed at C, the position of the image will also be at C, and the size of the image will be same size. As the position will change, then the size will also be same. Then the nature of the image will be real and inverted. When the object is placed between F and C, then the position of the image will be beyond C. Size of the image will be enlarged. The image will be expanded. It will get enlarged. Then the nature of the image will be real and inverted. Next, if the object is placed at F, the position of the image will be at infinity. The image will be at infinity. And the size of the image will be highly enlarged. And the nature of the image will be real and inverted. The image will be real image and it will be inverted. Next, if the object is placed between P and F, the position of the image will be behind the mirror. And the size of the image will be enlarged. The nature of the image will be virtual and erect. Okay. Next, in case of convex mirror, if the object is placed at infinity, the size of the image will be at focus. Next, the size of the image will be highly diminished. The position of the image will be at focus. The size of the image will be highly diminished. And the nature of the image will be virtual quantities. It will be virtual. Next, if the object is placed on principal axis, what is principal axis? The line that is passing between center of curvature and pole is called as principal axis. When the object is placed on the principal axis, then the position of the image will be between pole and focus. The position of the image will be between pole and focus, and the size of the image will be diminished. The image will be diminished, and the nature of the image will be virtual and erect. Okay, yes. What we have seen in these diagrams, we have seen as a summary in this tabular column. Okay, this tabular column can be asked in your detailed answer. You have to prepare all these content. Okay, yes. We have seen what are called as spherical mirrors. What are called spherical mirrors? The mirrors that have curved surfaces are called as spherical mirrors. Spherical mirrors are of two types, namely concave mirrors and convex mirrors. Yes, we have seen what is meant by concave mirror and what is convex mirror. Then we have seen the terms that are related to spherical mirrors. Yes, what are all the terms that are related to spherical mirrors? Aperture, radius of curvature, center of curvature, pole, principal axis, focal length. Yes, what is focal length? Focal length is half of the radius of curvature. Focal length is represented by the symbol small f. F is equal to r by 2, where r is your radius of curvature. From that we have calculated radius of curvature, right? What is radius of curvature? Radius of curvature is equal to 2 into focal length. Next we have seen formation of image by a concave mirror and formation of image by a convex mirror. Then we have seen the summary for the image formed by concave and convex mirror in a tabular column. Yes. Complete your home assignment and submit it in your WhatsApp group. Rest of the topics we can see in your next class. Thank you, students.